pioneers in the halal industry. So, investing in infrastructure, certification, and marketing to establish themselves as leaders in the global halal market. On the other hand, if we talk about non-Muslim countries such as Thailand, China, India, Australia, New Zealand, they're also making significant strides in capturing a share of the halal market. So these countries are leveraging their technological advancements, agricultural resources, and multicultural societies to produce and export halal certified products to Muslim majority countries and Muslim consumers worldwide. And countries like Brazil and Singapore are also emerging as key players in the halal industry, and they are leveraging their expertise in agriculture and processing and logistics to tap into the growing demand for halal products. So, challenges in identifying halal products. The third point is about the challenges. I mean, despite the increasing demand for halal products, there are still challenges that are associated with verifying the authenticity of halal certified products. So, scientific innovations and advancements in packaging technologies have made it difficult to physically identify food components, and that pose challenges for consumers seeking halal products. So, traditional methods of inspection may no longer, I think, enough in ensuring the integrity of the halal supply chains. So, that's the reason there is a pressing need for sensitive, easily performable, and reliable scientific methods that are sensitive to verify the ingredients in halal food products, because it ensures transparency and trustworthiness in the halal certification process that allows consumers to make informed choices about the products they consume. So the global halal market is just categorized by intense competition among countries that are seeking to capitalize on the growing demand for halal certified products. Understanding the dynamics of this market and addressing challenges that are related to product verification are essential for businesses and regulatory bodies that are aiming to thrive in the halal industry. Right? Next slide, please. Yes, we just discussed about the challenge of identifying the ingredients in the halal food products. So now we will discuss about it in detail, like critical processes of monitoring and detection. I hope all of you are not getting bored. So, discussing the critical processes of monitoring and detection in ensuring the authenticity and compliance of halal food products. So, monitoring includes ongoing surveillance and oversight of halal food production processes, from sourcing raw materials to final packaging and distribution. And it's a proactive approach to maintain compliance with the halal standards and building consumer trust. If we talk about detection, it involves the use of analytical tools and technologies to identify any deviation from halal standards or the just the presence of non-halal ingredients in the food products. So these techniques play an important role in verifying the integrity of halal certified products and ensuring their compliance with the religious dietary lines. So methods for detection and monitoring include FTIR spectroscopy, electronic nose technology, differential scanning calorimetry, molecular-based techniques. So we will discuss about all of the four technologies in detail in the coming slides, but let me provide a brief overview. Like FTI, if I talk about FTIR, this technique analyzes the chemical composition of substances by measuring the infrared just light absorption when the sample is exposed to the light. So it's effective in identifying any non-halal ingredient that is present in the food that ensure compliance with the halal standards. So if we discuss about just ENOS technology, I mean, let's further discuss about differential scanning colorimetry. I mean, it is a thermal analytical tool that is used to study the thermal properties of materials. It helps to identify non-halal fats or oils by analyzing their melting point, providing insights into the composition of food products. So if we talk about electronic nose technology, it just mimics the human sense of smell using sensory arrays to detect and analyze odors, and it is utilized to assess the aroma profile of food products and identify any deviation that may indicate the presence of non-halal ingredients or improper handling practices. And molecular biological techniques, these techniques such as polymerase chain reaction and DNA sequencing, they are used to detect specific DNA sequences in the food products. And these techniques enable identification of halal compliance species and the detection of any non-halal ingredient or contaminants present in the food products. But still, you must want to know about why monitoring and detection is essential. First of all, it brings consumer trust. Regular monitoring and detection brings confidence among consumers, and that assures them the authenticity and compliance of halal certified products. And next one is market access. Compliance with the halal standards is prerequisite for assessing global halal market, and effective monitoring and detection just facilitate market access by ensuring compliance with stringent halal requirements. And next one is brand integrity. For businesses, maintaining the integrity of their halal certified products is important for preserving brand reputation and competitiveness in the market. And health and safety monitoring and detection obviously help consumers health by detecting and preventing the presence of any non-halal ingredient or contaminants in the food products. So monitoring and detection is essential component of just ensuring the integrity and compliance of halal food products. So by using these advanced analytical techniques and technologies, businesses can uphold halal standards that maintain consumer trust and access global halal markets. Next slide, please. Now we will just discuss in detail about FTIR. It is a powerful analytical technique. It stands for Fourier transform infrared spectroscopy. And it is an analytical technique that is used to identify and quantify the chemical composition of substances by measuring the absorption of infrared light. So in this technique, sample is exposed to infrared radiation across a range of frequencies. So as the infrared light interacts with the sample, certain wavelengths are just absorbed by the molecular bonds within the sample, and that cause them to vibrate. So by measuring the intensity of the absorbed light at different frequencies, this FTIR can generate a spectrum that provides information about the types of chemical bonds that are present in the sample. So, in the context of a halal food analysis, FTIR plays an important role in detecting any deviation from halal standards, and that ensures the integrity of halal certified products. So, food samples, including chocolate, cake, and biscuits, let's suppose that they were analyzed using FTIR spectroscopy to identify differences in their spectral profiles, because we will get different spectrum for all of the three products. And this analysis allows for the rapid and accurate detection of any non-halal ingredient that may present in these products that can present in chocolate, cake, or biscuits. And by combining FTIR technique with chemometric analysis, researchers, they just did research and they were able to detect large adulteration, and its source is pork, and they were able to detect it at levels as low as 3%. So this demonstrates the sensitivity and reliability of FTIR in identifying non-halal ingredients and ensuring the authenticity of halal certified products. So this spectroscopy just offers several advantages as a detection tool. It provides rapid results with analysis that is typically completed within 2 minutes, and that make it suitable for just screening of food samples. So it is simple. This technique, FTIR, is simple, accurate, and reliable that offer consistent and that just provides us consistent results. And plus, it is an environment friendly tool. What does mean by this? That it is an environmental friendly tool? It means it requires minimal sample preparation and it generates minimal waste for the analysis. So it provides information about specific functional groups that are just present in the food sample, that helps us in the identification of key components and potential adulterants. So different FTIR calibration models are essential for just ensuring the accuracy and reliability of FTIR. And calibration is very important for every equipment that we use in the lab. And these models are developed using known standards and reference materials to calibrate the instrument and validate its performance. So by just establishing robust calibration models, researchers can confidently analyze food samples and they can detect any deviation from halal standards. So FTIR is extensively utilized in the food industry for various critical processes. It plays a pivotal role in analyzing the chemical composition of food ingredients. It ensures accurate labeling, nutritional information for the consumers, and it maintains adherence to predetermined quality standards. It serves as a reliable tool for verifying the authenticity of food products and detection of any adulteration, adulterant, or any contaminant. So it ensures compliance with the regulatory requirements and meeting consumer expectations. It also helps us in allergen detection to safeguard individuals with food allergies by identifying allergenic substances that may be present in the food products. And also plays a vital role in food safety assessments by detecting contaminants, toxins, microbial contaminants, by ensuring the safety and well-being of consumers. So it also facilitates process monitoring in food processing and manufacturing operations. It optimizes processes and maintaining product quality and consistency. So it is important tool for just ensuring the integrity, authenticity, and safety of the food products that builds consumer trust and confidence in the food product. Now we have discussed in detail about FTIR. Next slide, please. And next technique tool that we are going to discuss in detail is the differential scanning colorimetry. And we will discuss about its application in the food industry, specifically relating to the halal identification of the products, identification of the non-halal ingredients in the food product. And it is a thermo-analytical technique that is used to monitor changes in the physical or chemical uh, of the material by detecting heat changes. So DSC, I mean differential scanning calorimetry, it measures how much heat is required to increase the temperature of a sample compared to a reference. So this method is important, instrumental in understanding the thermal behavior of food sample, which includes melting points, crystallization, and other thermal transitions. And one of the primary uses of DSC, differential scanning colorimetry in the food industry, is to identify and characterize different fats and oils. For instance, the thermograph profile that is obtained from this colorimetry, and we can reveal the presence of lard in a food sample. And this is important for ensuring compliance with the halal standards, as lard that is derived from pork is prohibited. So its identification is important. By analyzing heat flow associated with just melting or crystallization events, so this